All right, so another application of finding the intersection of straight lines is in break-even analysis. So if you're running a business and you have certain costs and you have certain revenue streams, um, if your cost is higher than your revenue, then you're going to be operating at a loss. If your revenue is higher than your cost, then you'll be operating at a profit. And so that point where the cost and revenue cross each other is where the cost is equal to the revenue, and then you have zero profit. So that's the break-even point, right? If you operate if you operate above that level, above that break-even point, producing more or selling more, you operate at a profit. If you're below that break-even level, then you're going to operate at a loss. So, and the point at which those two lines cross is the break-even point. So we're looking for the point where the revenue and the costs are equal to each other, and that point is called the break-even point. And the x value, which is the quantity, is the break-even quantity. The y value, which is the revenue, is the break-even revenue. Okay, so let's take a look at example 3. So Prescott manufactures its products at a cost of $4 per unit and sells them at $10 per unit. And the firm has a fixed cost of $12,000 a month. So the first thing we want to do is find the cost and the revenue functions for this company. All right, and we can do that. Let's first of all find the cost function for this company, because it says that they're manufacturing their products for $4 a unit. All right, so it costs them $4 per unit. So we're going to multiply that by the number of units produced, and they have a fixed cost of $12,000 a month. Okay, so if we add those together, we get their total costs. We have the variable cost and the fixed cost, and then we have the revenue. The revenue depends on how many units of whatever these things are they produce, and so they're going to sell them at $10 per unit. Okay, so the revenue will be 10 times the number of units they sell. All right, so if we want to know where they break even, then we just need to set the cost equal to the revenue. And so we're going to set these two equations equal to each other. Whoops. Equal to each other. So, oops, oh my gosh. 12,000. Okay, so 4x plus 12,000 is equal to 10x, right? That'll be where the cost is equal to the revenue. So I'm going to subtract 4x from both sides. That'll give me a 6x over here is equal to 12,000. And then divide both sides by 6. So I'll get x is equal to 2,000. Okay, so that is my break-even quantity. Let me label that. Break-even quantity. Okay, that's my break-even quantity. So now I want to also find my break-even revenue. So I'm going to calculate the revenue when the quantity is 2,000. Right, so that's just going to be 10 times 2,000, right? Because we're selling these things for $10 a unit, so we get $20,000. Okay, and that's my break-even revenue. Okay, and together, so I'll just put a little arrow here. Together, that's considered the break-even point, right? The combination of the break-even quantity and the break-even revenue. All right, so let's take a look at part B. What is the loss sustained if the firm is only if only 1,500 units are produced and sold in a month? Okay, so that's a point below, right? That's below the break-even quantity of 2,000. So we would predict that we're going to have a loss. So let's calculate what that loss is. So let's find the revenue at 1,500 units. So we're just going to take $10 a unit times 1,500 units, and we get $15,000. Okay, so that's how much we'll take in by selling our units, whatever these are. And let's figure out what the cost is, though. So $1,500 or 1,500 units. At 1,500 units, it costs us $4 per unit to produce them. And then we have $12,000. We have a $12,000 fixed cost. And so if we add those together, we get $1,800. Or sorry, $18,000. $18,000. All right, so you can see the cost is higher than the revenue. And the profit is just going to be the revenue, right? The revenue minus the cost. So in this case, $15,000 in revenue minus $18,000 in cost leaves us with a loss of $3,000, right? It's going to be negative $3,000, which means a loss. Oops, loss. Okay? So that's our loss if we only produce 1,500 units. So what happens if we make 3,000 units? We make and sell. Of course, we have to assume that we're selling these. If we sell 3,000 units, right? We can calculate our revenue at 3,000. That's going to be just $10 per unit times the number of units. Gives us a revenue of $30,000. All right. And the cost at 3,000 units is going to be $4 times 3,000 units, and then plus the fixed cost of $12,000. All right. And so we get $24,000 in cost. All right. So then the profit, again, is just the revenue minus the cost. So we're going to get $30,000. $30,000 minus $24,000 gives us a positive, in this case, $6,000. So this is a profit. That's a good thing. So we have a profit now. It's a positive profit. Negative profit would be loss. All right. And finally, it says, how many units should the firm sell to realize a minimum profit of $9,000? All right, so we want a profit of $9,000. Well, first of all, it would be helpful to have a function for profit. Right now, what we have is a function for cost and a function for revenue. But we could create a function for profit by just taking the revenue, R of x, minus the cost, C of x, okay? And just combine them into one function just for profit. So we have 10x minus this whole quantity, 4x plus 12,000. Okay, can't forget the parentheses. So otherwise, because we're subtracting this whole thing, the whole cost function. All right, so we have to distribute that minus sign. So when we do that, we can make this into a plus and then change the signs in here, make them both negative. So then we have 10x plus a negative 4x gives us 6x, and then minus $12,000. Okay, so now we have a function for profit because we're interested in finding when the profit is equal to $9,000. So we'll just take that and set it equal to $9,000, right? So let's add the $12,000 to both sides, right? And we get 6x is equal to $21,000. And then if I divide both sides by 6, I get x is equal to 3,500. Okay. So at that level of production, 3,500 units, we will have a profit of $9,000. Of course, if we make more than that, if we make and sell more units than that, we'll make then our profit will be even higher. So All right, well, that takes care of that example, and I'll meet you in the next video for the next example.